AI's goal is to think humanly with agent, like a robot or program. But so far, robot is thinking rationally. That means everything must be able to measured by like a kind of number or ranking. So human acts with reasoning, but robot acts with behavior. So let's think about the Carol. I hope you still remember him. We learned at the first year of ComSci class. Carol is a robot, so Carol thinks only rationally. So we had Carol that move. Like, oh, we had Carol the pick beeper that was also rational, the measure, possible to measure behavior. It was also behavior. Then to pick beeper, Carol was able to check Carol the next to a beeper. It was reasoning, kind of, but it was still possible to check rationally because we had all the values about this map. Then Carol just checked the value which is stored on that coordinate. How about the reasoning? Did we have Carol that think? So far, Carol was not able to think. And our job is to make the Carol be able to think. This is one of the robot that it's a long time ago, the robot vacuum robot. Vacuum robot was able to sensing if there is a dirt or not and decide clean or not by checking dirt on the floor only. Because dirt on the floor was possible to measure. Let's think about like a human thinking. Let's name her as Lisa. I don't know why. Lisa's cleaning the room. Then let's just say there is dirt here. Lisa is a human, so thinking humanly. She has her own process, her own reasoning. After she cleaned only carpet or rug, then she will think it's cleaned. So her measurement depends on her opinion. Let's think about the agent one more time. Agent is sensing, then behaving. Depends on what was censored. So if you look at this agent diagram, there's no brain. There's no head. Agent does not think reasoning. Agent is just behaving. If you don't like this picture, you can think about the next picture. Now, this is the agent. What does? There's environment like a dirty room, then it senses the dirt, then it decides where to go, where the dirt, then do act. Then it's gonna change the environment, the room, and the clean, but only floor. I'm gonna go back. So basically, you can think about what is difference between acting humanly and acting rationally. Then whoever work is agent. Then we want rational agent. That means we would like to measure every single environment factors, like make it as a number or some conditions, then give it as an input to the agent. Then we are going to say that as each state. Whenever agent do behave, then if the environment is changed, that is each state. For the agent, right thing means the measuring is done, then depends on that number, a numeric value, then it's going to act in the right behavior. There are some more things in AI you can think about it. Yes, natural language processing was a very big thing like until like 20 years ago, but we are almost done. You can play with Google or Alexa, Siri. They're all using natural language processing. Not perfect yet because even though they can successfully speak in English, but they do not know how to react in some situations. That part, how to react, will be the machine learning part, like a deep learning. So how machine learns by itself will be your next topic in AI, because we try to teach the computer by ourselves, then we figured out it's not always perfect. It's really hard to communicate perfectly. So how about let machine learn by itself? That was the next step. Then nowadays, yeah, we're so far very good, good process, good progress in machine learning part. So when you learn AI in college or graduate school or in the industry, you're going to focus on more machine learning, how machine learns by itself. Task environment. You can think about what kind of environment and what kind of environment is possible to be measured correctly. First, the fully observable is very good. This means we know everything about the old data. So, for example, railroad map. We already know the whole, so we already know which city to which city the railroad will go. So that is fully observable. How about partially observable? Means some part is not really sure. Some part is observable. Then there are some unknown part. Let's think about you're driving a car. Around the car, you already know it's observable. That also some roads is very, very known. But some part of the road you do not know. In that case, your car will check by the sensor. So what's gonna happen? Then deterministic, stochastic, you read it. Another thing, another example of the partially observable is there's a room, two rooms, then one. This is from the textbook. It's a vacuum machine again, vacuum robot again. The first room, the vacuum machine can check. Let's think about there are multiple rooms. Can check the room, then it will clean. Then it already knows if there's a dirt or not. Locally, it can sense. However, the vacuum machine does not know if the next room has dirt or not. So it is possible vacuum machine goes to the cleaned room first, even though there is a dirty room next to it. So by just acting, then it can observe. This one is one of the examples, partially observable too. Let's think about which is easy to measure. If it's determined, easy to be measured, right? So when it's not known, when it's partially observable, how we'll figure out the optimal outcome? That is one of the goals of this course. To solve our situation, to let the robot solve, to let agent solve, we have to define the problem for agent. So agent will be able to sense and analyze the situation and decide the next action by itself. So defining a problem is very important in AI. If you fail to define a problem correctly, you will never get the solution. First, you need to think about what can be the initial state. Then you are going to decide which action options each agent will have at current state. So each state, you need to decide what action can be done. If I go back to the railway again, I'm going to start from LA, then to the DC. Initial state will be LA in this case. So LA station. Then actions will be the nearest city, but train can go from the LA to the next one. So next city will be the current state action. So I can say like a neighbors, like we already did in the graph lab. Then result will be from the current state. When I do one of the action, what is the next state? So I can say if I visit one of the city as Phoenix, LA to Phoenix will be the result. So I got a path. Goal test is my goal state. Actually, my goal state is DC in this case. Then there will be some cost. Some city is closer, so it's gonna cost small. Some city is far, so it's gonna cost more. So we need to know step cost from one state to the next state. When we did only one action, that is the step cost. Then when you combine the step cost, let's think about I went up to Dallas. In that case, now I have multiple states in one result. LA to Phoenix to Dallas. In that case, I have to know the total cost of this path. We call that as a path cost.